Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this lab we're going to be taking our next look at Linux from the CLI perspective. So we're looking at Part 3 of Lab 1.2.2. And so we're going to pick up right where we left off here. And let's take a look at what might be in that desktop directory that we have. And let's get a long listing. And so you can see there's a number of files that are in here. Our focus in this video and what you're going to be learning about are permissions and the impact that the different permission settings have on the files. Now, one of the first things that the Part 3 lab is asking you is there's a series of questions there. So it wants to know, what does the initial dash in the permissions mean? Well, that just means it's a regular file. When there's a dash there, if there was a D there, it's a directory. So in other words, the very first bit in the permission settings is the file type. Now, other things you might see in there, you may see an L in there, and that would indicate that you have a link. All right. So what would be in place of the dash if it was a directory? Well, we talked about that. It would be a D. Who do the next three letters, or what do the next three letters or dashes represent in the permission information? Specifically, we're looking at those. Now, those are the permission settings that apply to the owner of the file. And again, we know who the owner is because that is listed right here in this column. And so it's DEVASC. Now, if I was to transition out to my Mac, you can see I've got a Python prompt here, but let's scoot over here. If I was to say cd bin and say ls-l, you can see that we have all kinds of files here in the /bin directory. Now, the owner is root, and the group it belongs to is the wheel group. Now, if I was to go into my home directory and then into not /bin, but just the regular bin directory, you can see that what I have here is a regular, just a Python file called ip.py. Now, on the Mac, when you start to add permissions, especially execute permissions, you might see this little @ sign here that they tack on at the end. This is a Mac-specific behavior. And all that means is there's some sort of extended attributes that are attached to this file from the Mac perspective, right? And again, Max is Linux-like, but it is not running sort of like, 100%, Ubuntu Linux or anything like that, right? So it's Linux-like, but again, the behavior is a little bit different, but again, you can also see where the behavior is kind of the same. So let's step back now to the virtual machine and let's continue on. So the first three of the permission bits, right? The first bit is the file type. The next three bits are the permission bits for the owner. The next three bits are the permission bits for the group, right? If you're a member of this group, DEVASC. And then the final three permission bits are for everybody else, meaning if you're not the owner of the file and you're not a member of the group, those two sets of permissions wouldn't apply to you. So which sets of permissions do apply to you? The last three. Now, it asks you about the first instance of DEVASC. In the second instance, again, that's the owner and then the group. And then what does a permission type of R, W, and X mean? Well, it makes a lot of sense here. Read, write, and execute, right? And it means the same thing over and over again. So read, write, execute, read, write, execute, read, write, execute. Now, we're going to go ahead and pull out the drawing tool here real briefly because it's important to point out that each of these bits has a value attached to it, right? And the values are the same, and you can think of it like a logical separation here, right? So the read permission bit has a value of 4. The write permission bit has a value of 2. And the execute permission bit has a value of 1. And again, you can think of this as we would simply continue to go up if there were other bits over here to the left, but these low order bits here have a value of 1, 2, and 4. So when all 3 of the permissions are on, meaning you see the letters there, that indicates the permission is on, it would be a value of 7. For the group right here, R-X, so read permission is on, write permission is off, and execute permission is on. So that would be 4 plus 1, that would be 5. So we have 7, 5, and then obviously that's the same, 7, 5, 5. So that would be one way that we could approach changing the file system permissions on something. If we wanted it to be 755, that's what it would look like. And we're going to take a look at some examples of that. We're also going to see how you can simply flip the execute bit on across the board, or maybe you just want to do it for the user, or maybe you want to only do it for the group. And so we'll see some examples of that as well. But that's what the permissions mean. This is how you can figure out the numerical representation of these permission bit settings. And we'll see some other ones as we make our way through this activity. All right. So now what it wants us to do, it wants us to head down into the documents directory, right? So let's go into the documents directory. And if I do an ls or even an ls-la, you can see that the documents directory is empty. Now they're going to have us use this echo command. So I can say echo hello. And this is not a Python command. This is a bash shell command, right? And it would also work with the original Bourne shell. But all it's doing is it's simply going to echo out to us what we tell it to echo out. So again, I could echo, 192.168.1.10 is my IP. And it's going to simply echo that back out to us. So what this lab is showing us now is it wants us to echo out the ls command, and they actually show us doing it from the home directory here. So it wants me to echo out ls:/desktop. In other words, this output, and we want to redirect it. That's what the arrow means. Think of it, it's like that greater than sign there is saying dump it into myfile.sh. And so we're not going to see any of the output that we would see had I ran that command. Whoops. And it looks like I cannot get there. Do we need to be in the documents directory? Let's see if we rerun that command. I'm just hitting the up arrows there. Oh, okay. It wanted us to be in the documents directory. I apologize. So we want to stay in that documents directory, run that echo command, and let's see what that command would have produced had I just ran it. And so it just gives us a listing of the files. In this case, these look like they could be all executable because they're green, meaning that the execute bit is on. So it just wants to put those files into a file called myfile.sh. And so there is myfile.sh. And so what would the numerical value be for those permission bit settings? Well, read and write is 6, read and write is 6, and then read is 4. So it'd be 6, 6, 4. Super simple. If you can add to 7, you've already mastered Linux permissions. So let's go ahead and let's cat out the contents of that file that we just created. And so we'll say cat myfile.sh, and you can see that what does it contain? It contains that command ls:/desktop, which is what we had echoed out, right? So that echo command is just printing out what we tell it to echo out. Now, important to note that you do not see the list of files, right? So what if I wanted to get the list of files into that file? Well, I could say ls/desktop and then output that to myfile.sh. Now, there's something that's going to happen here, and I'm doing this intentionally. You'll notice we didn't see the output, right? Because again, we redirected it. That's what that greater than symbol is doing. It's redirecting the output of that command into that file. So now if I cat myfile.sh, you can see we have a listing of the files, but where did the command go? Where did the ls:/desktop go? Well, remember, we didn't echo that out. And when you use the redirect symbol, it's going to, if the file exists, it's going to overwrite what is in there with what you're telling it to put in there. So a single greater than is going to overwrite the contents of that file. For example, if I said echo hello and we output it to myfile.sh, now when I cap myfile.sh, it just says hello, right? So all of this other stuff is gone. So when you use a single greater than sign, if the file doesn't exist, it's going to create it. And it's going to put whatever you tell it to redirect into it, it's going to put it in there. If the file does exist and you're redirecting output to it, it's going to overwrite that file. So make sure that you are aware of that. All right, so now we're going to try to run myfile.sh. And in fact, let me move this out of the way here. And let's get back to, whoops, click back in there. Let's get back to that file in the context that they want us to have. And it's right there. So I say echo, and then inside double quotes, ls./desktop. That's what's going to go inside of my file. I cap myfile.sh, and that's what it says. So the period also has another purpose. The single dot. Not only does it mean the current working directory, but this is a way to say /, and that's meaning, hey, I want to run myfile.sh. Now you'll notice if you're hitting the tab, trying to get tab completion, it doesn't work. Because right now Linux says, well, wait a minute, you want me to execute something. The execute permissions are not set on myfile.sh, which is why we end up with this error here that tells us permission denied. So if we were to do a long listing on myfile.sh, you can see the execute bit is not set anywhere on that file. Now, there's a number of ways we can fix this. I'm going to show you a couple here. So the lab is going to show you chmod, and they have +x on myfile.sh. So let's see what the result of that is. Oops, sorry, ls-l, myfile.sh. So what that did was it added execute permission for everybody, the owner, the members of the group DEVASC, and then everybody else who's not the owner and not a member of that group. So everybody can attempt to execute this command. So now when I say /myfile.sh, the tab completion now works. When you hit the tab key after I typed in my, it works because now Linux says, oh yeah, well, he wants to execute something here. And then it says, yeah, myfile.sh has the execute bit set. And we hit enter. And what does it do? Well, it's just running the command that we echoed and redirected into the file. So back to the permissions on myfile.sh. What if I only wanted the owner of the file to have execute permission? What would I have to change the mode to or change the permissions to? And we do that with the chmod command, right? And we did that with the chmod +x above. So I don't want anybody else to be able to execute it, only the owner. So that would be 7, 6, and then we'll put the permissions back to what they were, 4. So chmod 764 on myfile.sh, and I say ls-l, and there we go. So read, write, execute for the owner, read and write for the group, if you're a member of that group, and then only read for everybody else. And that means that if you're not the owner and you're not in the DEVASC group, all you can do is display the contents of the file. Now, that is a sort of a quick run through on permissions. What if I wanted to use the, or if I wanted to add execute permissions for only the group? I could say G + X, right? So group, instead of just doing the +X, which gives it to everybody, if I said G + X, and then myfile.sh, and then said ls-l, you can see we've added it to the group. What if I decide later on, yeah, you know what, the group doesn't need to have it? What if I did G - X, right? In other words, plus to add that permission setting, minus to take it away, and we do an ls-l, and you can see that it's gone, right? So that's another way you could do it. What about for a different permission setting, right? What if you wanted everybody to be able to read, write, and execute? That's the easy one. 777 myfile.sh and we do an ls-l, and all the permissions are open for everybody. But we probably here prefer, and I'm just hitting the up arrow, probably here prefer that the owner can execute it, but nobody else can, right? Okay, so that's kind of a quick look at the file system permissions and how you might calculate it numerically and use it with the chmod command, and then how you can use the +x with the owner, the group, and usually they say the user, the group. So let's go ahead now. It wants us to take a look at changing the owner, right? Because you can see the owner is DEVASC. So I'm going to say change own root on myfile.sh. Now it's basically saying, hey, change the owner from DEVASC to root on that file. But we're going to get an error here. And it says operation not permitted. So again, this is where sudo comes into play, and we say sudo change own root on myfile-sh. And so now when we say ls-l, you can see that the owner for the file is no longer DEVASC, it's root. Well, who am I? And we can see that with the ID command. And user ID is the UID. So me, I'm just DEVASC. So all right, I want to execute my file and you can see the tab completion is no longer working because I'm no longer the owner of this file. Yes, I'm in the group, but I don't have execute permission for the group, and everybody else only can read the file. So if I said myfile.sh, here we go again, we're going to get permission problem or permission denied here, right? Well, what do I have to do? Okay, well, can I do a chmod on this now? And I'll say chmod g plus x on myfile.sh. Operation not permitted because only the owner can change the permission, or the root user, right? So what if I was to say sudo, and let's go ahead and tee this up here, and now say ls-l myfile. So you can see the root user can do, because the root user can do pretty everything, right? The root user is the all-powerful. So now if you're a member of the group, you should be able to execute that. So when I say /my and hit tab and it completes, that tells me, hey, all right, I'm good to go here. And I hit enter and it works, right? So very, very detailed permissions as to who can do what, right? Depending on whether you're the owner of the file, whether you're a member of the group. And the reason that I can execute that file here now is because I'm a member of the group. All right, so now we're going to talk about moving some files around. Now, this is not deleting files. It's not making a copy. This is relocating a file to somewhere other than where it currently resides. So I'm going to say move, which is just the mv command, myfile.sh, and we're going to put it in. We're going to use the absolute path name, home devasc/desktop. Now, that's one way I could run this command. Hit enter, and it's going to work great. And we need that trailing / here to basically separate the name of the directory from the name my file, right? Because we're putting it in there with the name of my file. Now, how could I shorten this command? Yeah, exactly. Remember, /home/devasc is really tilde, right? The tilde represents /home/devasc. Now, if I wanted to give it a different name when I moved it, I would put that name right there, right? But we're going to keep the name that we have, myfile.sh. So now that I've put it there, right, it's at desktop myfile.sh, I can say, and they actually want me to do a /desktop here. Let's list things out. Did it get moved here? Yeah, there it is. It's on my desktop. In fact, I guess if we were to drop the icon down, there is myfile.sh right there on our desktop. And so we can see that there. So we want to return the file to the documents folder, right? So how could we do that? Now here's where I could say, and actually where are we at in the file system here? So we're in the documents directory. So the command that they're showing is .desktop myfile.sh, and I'm going to just put it right here called myfile.sh. And that's how I can move it right back. Now, there's a shorter way to do this. The lab shows you this, and this is why I'm trying to add some value here. But if I'm putting it in the directory I'm currently in, if I'm moving it to the directory that I'm sitting in, what shortcut represents the current working directory? The dot. And that's going to do it. ls-l, and we moved my file back, right? So instead of having to type the name out, typically you're not going to type the name out of the file unless you are renaming that file for some reason, right? But if I'm just saying, hey, move from that directory right there, this file, and put it here in the directory I'm currently sitting in, we don't have to use the name. It would work with the name, but we can just put the dot there. And that represents the same thing. Now we want to rename the file. So here's all I would have to do, is say move myfile.sh and give it some different name, right? So we'll say myfile underscore renamed.sh. And when I type ls, you can see there it is, ls-l. And we have successfully renamed that file. Now, what if you wanted to copy the file? So I could say copy myfile.sh, and this is going to leave the original file, the myfile underscore renamed.sh. And I'm just making a copy of it. And this is not always such a, or I should say, this is always a good idea when you're getting ready to edit anything. Whoops, that renamed and copied.sh. And then we'll do ls, we'll do ls-l. And so we have a backup copy. So if I was to go into myfile underscore rename.sh and make some changes and then break something for some reason, then I could always have a backup copy there that I can use, right? Now, what if I want to get rid of a file? I want to remove a file. So I would say myfile renamed underscore. Now I can do tab, and that's going to complete it once it's uniquely identified that file. And then that file is gone. And I say ls-l, and the file is gone. And when it's gone forever. I can't pull that file back from the CLI here. If you go out to the desktop, there is no trash icon out here. There may be a trash, there it is. There may be a trash folder of some kind, but you can see that there's nothing in here, right? So know that when you're removing files, right, that they're gone unless you set it up to keep the file with like maybe an alias of some kind, which is like a more complex command for the remove command. And you could Google that. In fact, what if you were to go out to ChatGPT, right, and say, create for me a bash alias that when a file is removed, it moves it to a trash folder. And let's see what ChatGPT says, because this is probably going to give me the alias to do exactly what I need it to do, or an example of that, right? And we can define that in our bash.bashrc, and there we go. So move target directory $home.trash, and then we resource it. So that way when I use the rm command, it's actually aliased out to move the file into a .trash directory in my home directory. So that way, if I was to remove things maybe by accident, I could go back in there and sort that out. So ChatGPT, pretty cool. Okay, now we're going to talk about redirection here. And we've already kind of covered redirection. Excuse me. So I can say echo Linux is awesome, right? AWE, whoops, ESOME. And they want us to redirect this into this file, linux.txt. Right? So if I was to cat linux.txt, it just has in there what we wanted. So I can cat that file out and then redirect that into another file, right? So that's another way to make a copy. So if I cat linux2.txt, it says the same thing. So basically just created a file. Now, what about appending, right? I don't want to wipe the file out. I want to append something to the end of the file. So I'll say, I love Linux, right? Now to append, meaning we keep the contents of the original file and we just put this at the end, I'm going to say, I love Linux and, oops, sorry. What did I leave out there? Oh, linux2. I mean to do cat. I wanted to do echo. All right, so there we go. So now we're going to cat out, I was thinking ahead there, we're going to cat out linux2.txt, and you can see that it has the original Linux is awesome line and the I love Linux line. And so that's how you can append information to the end of the file. Now, they go over VI, however, VI is pretty complex, so we could say VI linux2.txt, and it's going to open the file up into VI. Now, the A key, it can be used to append, right? And so now if I'm typing stuff, and this is where it gets a little tricky, so what you should do here is you can follow along with the lab. I'll hit escape a few times. Now they want you to do a colon. They talk about yanking output, so if I hit Y, Y, and P, that like copies a line. And if you keep hitting P after you copy one line, it's going to continue to do that, paste that line over and over again. So Y, Y is yank, P stands for put, and so I'm just putting that line that I just yanked right there. Now, DD, right, is going to delete a line. Remember, I had to hit the escape key after I hit the little A, because escape puts me back into command mode, as opposed to input or insert mode, where you're actually typing things out. So we're going to save the file from command mode, hit escape a few times. We're going to do a colon W, and then I'm going to give it a new file name. I'm going to say linux3.txt and hit enter. And you can see, hey, it saved it. There's 826 characters in there, 21 lines long. Now, how do I quit out of here? Well, there's a couple ways you can quit. You can do :Q, right? Or what I do is just hold down the shift key and hit ZZ. And then that gets you back out, right? Again, if you get stuck, hit the escape key a few times and then shift ZZ, puts you right back here on the CLI. And so now we can cat out linux3.txt, and it's got all of that great stuff that is in there. All right, well, that is going to do it for this tutorial. Again, we took a deep dive look at the permissions. We took a look at changing the permissions using numerical approach as well as using the alphabetical approach with the letters. We looked at redirection, the cat command. We looked at moving things, removing things. We even saw ChatGPT give us an alias that we could dump into our .bashrc file to save things that we're removing instead of actually removing them, and just to dump it into a hidden directory, hidden file in our home directory. All right, hopefully this is helping you guys out. Thanks so much for watching, and as always, I hope to see you in the next video.